So question number 56. If the temperature of a hot body is increased by 50%, temperature is increased by 50%, the amount of radiation emitted by it would increase by nearly by. So it is from from the radiative heat transfer, that is the application of Stephen's-Boltzmann law. We have Q1 equal to epsilon sigma T1 to the power 4, where T1 is the temperature in Kelvin. Now they have told that the temperature of the hot body is increased by 50%. So for case 2, Q2, let it be case 2, let this be case 1. So T2 is equal to temperature is increased by 50%. So T2 is 1.5 times T1. So it is increased by 50%. So basically Q2 we can write it as Q2 equal to epsilon sigma T2 to the power 4. That is equal to epsilon sigma T2 is 1.5 times T1 to the power 4. The amount of radiation emitted in percentage they have asked. So Q2 by Q1 in percentage equal to Q2 is epsilon sigma 1.5 T1 to the power 4. Q1 is epsilon sigma T1 to the power 4. Q2 by Q1 is equal to 1.5 into T1 2 raised to 4 by T1 to the power 4. So this will get cancelled into 100. This 100. So that is equal to 1.5 to the power 4 into 100. So that will be equal to 506.25%. So option D, 500% is the right answer. So question number 57. The value of shape factor for two infinite parallel planes separated by a distance x. There are two infinite parallel planes. The value of shape factor. Shape factor is also known as angle factor. Angle factor or view factor or configuration factor, etc. So for infinite parallel planes, shape factor is defined as the fraction of radiative energy that is diffused from one surface and strikes the other surface directly is known as shape factor. So Fij is usually the notation for shape factor, the fraction of radiation energy leaving the surface I and impinging on surface J. So since it is two infinite parallel planes, the shape factor is basically unity. Answer is 57B. So for plane surfaces, so if this plane surfaces, so fraction of radiation energy leaving the surface and impinging on another surface is, that is F1. Here fraction of radiation energy leaving the surface 1, let this be the surface 1, and impinging itself on surface 1 is 0. Now for convex surface, so let this be convex surface. Again fraction of radiation energy leaving this surface and impinging on the same surface is again 0. But however for concave surface, so some part will get absorbed, so F11 is not equal to 0. So this is very important. So but our question is the value of shape factor for two infinite parallel planes. So infinite parallel planes separated by a distance x, the value of shape factor is, answer is 1. However, this is based on the assumption that there is no medium, no absorbing medium such as air in between the surface. The emissive and the reflective properties are constant over all the surface. So the emissive and reflective properties are also constant. So basically the answer is 57. B is the right answer. So question number 58. The ratio of heat transfer by convection to that of conduction is called. So answer is option B. Nusselt number is the right answer. So we have Nusselt number is equal to HL by K of the fluid, or we can rewrite it in the form of H by Kf by L, or that is equal to H A delta T by K A delta T by L. So this is basically, numerator is basically heat transfer by convection, and denominator is basically heat transfer by conduction. So this is Newton's law of cooling, and this is Fourier's law of heat conduction. So ratio of heat transfer by convection to that by conduction in a fluid is called Nusselt number. Question number 59. Which dimensionless number has a significant role in natural convection? Answer is A. Grashoffs number. Grashoffs number is defined as inertia force into buoyancy force by viscous force square. So expression for Grashoffs number is G beta delta T L cube by nu square, where nu is the kinematic viscosity, delta T is the temperature, gradient G is the acceleration due to gravity, L is the characteristic length, etc. So dimensional number, and it is basically used in natural convection problem. For forced convection, it is Reynolds number. Forced convection. And it is defined as, the formula is given as rho Vd by mu, or equal to Vd by mu. So for mixed convection, we have the dimensional number, both Grashoffs number and Reynolds number is significant. So question number 60. For the same operating temperature limits, the COP of a heat pump is, we know that COP of heat pump is 1 plus COP of a refrigerator. So 60, option B is the right answer. 61. A Carnot refrigerator rejects 3000 kilojoules of heat at 400 Kelvin while using 1000 kilojoules of work. The lowest operating temperature in the cycle is, so lowest operating temperature we have to find out. So we'll quickly draw a representative diagram. We have a refrigerator operating between sink and surroundings. So Carnot refrigerator rejects 3000 kilojoules of heat. So it basically rejects 3000 kilojoules of heat at 400 Kelvin. So this is at 400 Kelvin. We have to find out what temperature is this while using 1000 kilojoules of work. So this is 1000 kilojoules. Lowest operating temperature is this temperature. So let this be the refrigerator. This is basically the refrigerating effect. Now we know that COP is equal to, of any refrigerator, is desired refrigerating effect by work input. So that is equal to RE by 1000 in this case. Now we have RE plus 1000 equal to 3000. So here check the direction of the arrow. So RE goes in 1000 kilojoules here, so is equal to 3000. So therefore RE equal to 3000 minus 1000, that is equal to 2000 kilojoule. So again substituting it here on this, in this equation, we have COP is equal to RE is 2000 by 1000, that is equal to 2. Now they have told that it is a Carnot refrigerator. So basically we can write COP of a Carnot refrigerator as T lower by T higher minus T lower, that is in terms of temperature. So that is equal to 2 from here. Now equating or solving this, so TL equal to 2 times TH minus TL, that is equal to 2 TH minus 2 times TL. Now taking this to this side, so we have 3 TL is equal to 2 TH. Here TH is basically 400 Kelvin, so that is equal to, therefore TL is equal to, TH is 400 by 3, so 800 by 3, that is equal to 267 Kelvin. Let's see the answer. 267 Kelvin. Yes, option C is the right answer.